Welcome back, learners. So as we have said before the ad break, we are going to jump into our last concept of this lesson, where we'll be looking at the national electricity grid. So to begin, we should know that all power stations in South Africa, including the hydroelectric power and the nuclear power stations, form part of the national electricity grid. So we should also know that this electricity grid, it supplies the entire country with electricity. So the grid is a system, so we need to understand what a grid is. That's now a system of interactive parts, and a change in one part of the network affects other parts of the network. So in this particular case, this is our national grid, and we are saying that by changing one part of this network, by changing just one thing, we are going to be affecting the functioning of the entire grid. So therefore, it's very much important to take care of our national grid so that it doesn't collapse. So, we also should know that the electricity that is generated by various power stations must be supplied to the grid at exactly the right voltage. So should we now supply the grid at a low voltage, that means we cannot be able to use it. We need to do something to it in order for us to be able to use it. So if more electricity than needed is available, so if it happens that we supply more energy than what we need, then it is used for the purposes such as pumping water to high-laying dams. However, if we supply less energy, or if less energy is available for us to use than what we need, then load shedding, something what we know as load shedding, may be initiated. So, to reiterate, if more electricity than needed is available, so we can use the surplus to pump our water into higher-laying dams. However, should we then have less electricity than what we need, then this is going to be initiated, the load shedding. So, power stations are usually located near coal mines, away from towns and cities. Remember, because in South Africa we mainly use coal, we need to make sure that our power stations are closer to coal so that we can easily get access to the coal whenever and however we need. So these power lines that are now going to be transporting electricity from the power plant into the factory or into the houses, these power lines, they have they are basically high voltage cables or transmission lines. So the lines that we are seeing that are transporting our electricity from one point to the other, they are high voltage cables. Now, these high voltage cables are used to safely transport electricity from the power station to the towns or to the cities, from the cities into your house, into the factory nearby, and to everything that is going to be using the electricity. So these power lines, or these transmission lines, they have certain resistance. Remember, resistance is affected again by the type of the material, the temperature, even the length of this particular material, in this case, the length of the cable, and the thickness of the cable. So the resistance in the cable causes much energy, about 15%, to be lost in the form of thermal energy. So as this electricity is transported from one form to the other, 15% of it is going to be lost in the form of heat, which is known as your thermal energy. The stronger the current, the greater the energy loss. So if the current that we are finding on these wires is very strong, that means even the amount of energy that is going to be lost as we are transporting this electricity is going to be higher than the 15%. But then the right type of material is going to now allow us to lose at least or at most 15% of the energy that we are going to be producing from the power stations. So due to the energy loss at high current strength, step-up transformers are used at power stations to increase the voltage to as high as 750,000 volts. So we are saying that due to the energy loss, remember, as we are losing the energy, we then now need to step it up, because if it gets to the factory, or it gets to the city in the amount that is not required, then we need then now to step it up by using the transformers. Remember, this energy can either be stepped up or it can be stepped down, depending on which is received by the city. if we are receiving less energy, therefore it needs to be stepped up. But then if more energy is received than what is required, then it needs to be stepped down. Then an increase in voltage results in a decrease in current strength. So when we are increasing the voltage, we are then going to be decreasing the current strength. So we are then saying, because of that, there is an inverse relationship between the voltage and the current strength. So the relationship between the voltage and the current is inversely proportional. When one increases, the other one has to decrease. This in turn decreases the amount of electrical energy that is converted into thermal energy in the cables. So when this happens, then the amount of energy that is going to be lost is also going to be decreased. So because we're saying that in turn decreases the amount of electrical energy that is converted into the thermal energy in the cables. Remember, in the cables we are losing energy in a form of thermal energy. So it is going to be decreased when this relationship is instituted. Now, in the cities and towns, the voltage decreased by a stepped down transformer, and the current is then going to be increased. So the voltage is going to be decreased by a step down. Remember, we've said if we get a voltage that is higher than what we need, something needs to be done. You're going to step it down. Now, it's stepped down in the transformer. However, if we get an energy that is lower than what we need, then that still needs to be stepped up. And remember, it is still stepped up in the transformer. So we should also know that the electricity that is supplied to houses at a voltage, it is supplied to houses at this voltage of 240 to 220 to 240 volts. Now, in terms of Eskom controlling the amount of energy that is being transported from one form to the other, Eskom needs to control the electricity supply and avoid grid overload. Remember, once we have the grid overload, that then means the energy that is demanded by everyone that is in this country versus the energy that is being supplied. If the energy demand is high compared to the energy supply, therefore remember, we can institute something called load shedding. Furthermore, a power surge a power surge occurs when the voltage suddenly spikes. So a power surge is going to occur when the voltage suddenly spikes. For example, when lightning strikes or when the power is reconnected after load shedding. Number 2, other causes of power surges include short circuits or short breaks in wiring system, or the switching on and off of electrical appliances that use a lot of electricity, for example, hot water cylinders. Number 3, power surge can damage sensitive electronic devices such as computers. So your computer can be damaged by a power surge. And remember, we know that a power surge occurs when a voltage suddenly spikes. When does that happen? After load shedding or when there's a lightning strike. In addition to that, a grid overload occurs when there is a big demand for electricity but not enough available in the grid. And remember, once the demand is not met by the supply, then in order to make sure that everyone at least gets some parts of electricity or some portion of electricity, we then need to institute the load shedding. Number 5, in such cases, power cuts or outages occur, as we have said, because the demand is not met by the supply. We then need to have the outages, which are known as your load shedding. Sometimes without warning. So sometimes they will not tell you that we are going to institute load shedding from this time to this time. Because if there's a great demand and that demand cannot be met, then the load shedding is going to be instituted without even warning. This is not only inconvenient, but can also be dangerous. For example, when life-supporting equipment suddenly stops functioning. So you can think of a patient in a hospital. When the load shedding is not announced, that there's going to be load shedding from this time to this time, and that machine that keeps that person alive, that life support, suddenly stops, it can be extremely dangerous to the people that are in hospitals, or actually to everyone, because you might be using certain appliances without knowing that the electricity will come and even come back at any time. So therefore, you need to always be careful when using electricity or when you are around electricity. So with all of that said, learners, I hope you had as much fun as I did learning about the generating of electricity, and I sure hope now you know that there are other alternative ways of generating electricity other than the one that we're using right now, the coal. However, we do know that each one of those methods, they have their own disadvantages. And with all of that said, until I see you next time, goodbye.